In this video, we're going to look at another method of finding approximate solutions for equations. This is called linear interpolation. And once again, the best way to do this is by an example. So let's look at this. Show that there is a solution of the equation fx is x cubed minus 3x squared plus 7x minus 9 in the interval 1, 2. Use linear interpolation, which we shall explain on the way, 3 times to find 3 approximate solutions, x1, x2, and x3, giving answers to 3 decimal places each time. Show that the root is 1.848, correct to 3 decimal places. Well, let's look for a solution. If we start off by looking at f1 to see what's happening in the interval 1, 2, f1, this is part A, is equal to 1 minus 3 plus 7 minus 9, and that is equal to 8 minus 12 minus 4. If we look at f2, f2 is equal to 8 minus 12 plus 14 minus 9. That is 1. So now let's have a look at a picture of this. So if we take an x-axis, then we can say first of all that when x is 1, y is minus 4, and so we are somewhere down there. And when x is 2, y is 1, so we're somewhere up there. And we're going to find our first approximation by finding out where the line from, you don't want that, finding out where the line from 1 minus 4 to 2, 1 meets the axis. So our first approximation, x1, is here. Well, let's just put 1 or 2 more lines on the diagram. We want that one, and we want that one. If we look at this diagram carefully, we can see that we have similar triangles. These 2 angles are equal, opposite angles. You've got 2 90-degree angles. The third angle must therefore be equal, and so the triangles are similar. If the triangles are similar, then the length from 2 to x1 divided by the length from x1 to 1. So if we're using similar triangles, we get the length from 2 to x1 divided by the length from x1 to 1 must be the same as the length of this line, which is 1, divided by the length of that line, which is 4. Notice we're dividing by the length, not the y-coordinate. So we get 1 over 4. If we multiply up by 4, we get 8 minus 4x1 is equal to multiplying by x1 minus 1, which gives us that x1 is equal to 9 over 5, which is 1.8. So that is my first approximation, just here. Let's now look at what happens if we look at f of 1.8, f of x1. f of 1.8, if we press the buttons on the calculator, is minus 0.288. We now draw another picture, and we have still got the point 2,1 above the axis that we had before, and now when x is 1.8, y is minus 0.288, and so we have another point here below the axis. Our next approximation is where this straight line crosses the axis, and as before, we've got similar triangles. 2 minus x2 divided by x2 minus 1.8, 2 minus x2 divided by x2 minus 1.8 is equal to the length of this line, which is 1, divided by the length of that line, which is 0.288. 1 divided by 0.288. Let's make that just a little bit nicer. And if we solve that, we get that x is equal to 1.8447. We were asked to do this 3 times, so that's the first 2. This is 1.845 to 3 decimal places. And now we must look at f of x2. We use all the figures, 1.8447, ... however much there might be, is equal to minus 0.01836, etc. And now we again have similar triangles. Can't find the mouse. Lost it. There it is. We again have similar triangles here and here. So we're looking at that length divided by that one is equal to 1 divided by that length there. So we have 2 minus x3 divided by x3 minus 1.8447, etc. is equal to the vertical length, which is 1, divided by 0.01836, etc. And if you press the buttons on that, you will get that x3 is equal to 1.84752, which is 1.848 to 3 decimal places. And you could carry on doing this many times to make your root more and more accurate. We were asked to show that this root was accurate to 3 decimal places, part C. Just to remind you what the equation was, this was f of x is x cubed minus 3x squared plus 7x minus 9 equals 0. And we're asked to show that x equals 1.848 is the root to 3 decimal places. There is only one way that your exam board accepts this. That is the way that you've been doing already in your ordinary A level, and that is to select the right interval. The first thing to do is to look at f of 1.8475. Press the buttons on that, and you get minus 0.00127 ... Press the buttons on 1.8485, and we get plus 0.004879. We have a change of sign. We also have a continuous function. Therefore, the root is in the interval 1.8475, 1.8485. And because we chose the right interval, that means the root is 1.848 to 3 decimal places. You can find this on pages 35 to 37 in the textbook. FP1.